Welcome to Excellent Grades Academy. This is Dr. Byson EM. Today, we're looking at gametogenesis. All right, so let's get into this class and learn what gametogenesis is. All right, so we're looking at gametogenesis. Okay, gametogenesis. So gametogenesis, this is the process by which gametes are sex cells. So just say sex cells are produced. So they're produced from the gonads. So the gonads are sex organs. Sex organs through the process of meiosis. Through the process of meiosis. All right. So the production of male sex cells and female sex cells is what is termed as gametogenesis. Okay. So gametogenesis is just made up of two words. So gameto is from gametes. Gametes are sex cells. And then genesis is simply the start or the production. So you see that the definition in itself is in the name. So the production of sex cells is what we know is known as gametogenesis. Gametogenesis in females. So gametogenesis in females, let me just write that down. Gametogenesis in females is called oogenesis. So it's called oogenesis. And gametogenesis in males. Gametogenesis in males is referred to as spermatogenesis. Spermatogenesis. Okay, so let's delve into these two processes and see how they happen. Okay, so oogenesis. So this is the production. So the production of female sex cells. So female sex cells. Female sex cells are known as ova from the ovaries. So the ovaries are the female sex organs. Most people confuse the female sex organs to be the vagina, but the vagina is just a passageway. It is just a canal. But the female sex organs are the ovaries. Okay. Now, oogenesis, what you need to know is that oogenesis starts in utero. Oogenesis starts in utero. What this means is that the production of ova, so the production of ova starts whilst the baby, the female baby, okay, the fetus, we don't call it the baby when it's in utero. The fetus is in the mother's womb. So is in the mother's womb. That's when oogenesis starts. So let me take you through how the production of these sex cells starts. Okay. So now there are what we call primordial sex cells. Okay. So primordial germ cells, called primordial germ cells, which are denoted as PGCs. So these primordial germ cells are the cells that are going to differentiate into cells that will give us the sex cells. All right. So the primordial cells are formed from the epiblast. From the epiblast. Okay. From the epiblast. And they move to the yolk sac. They move to the yolk sac. So these structures are formed in the second week of development. A video that we've already explained, and the link is in the comment section and in the description. So go and watch that video and you understand where the epiblast comes from and where the yolk sac comes from and how it is formed. Okay. So primordial germ cells are formed from the epiblast. And they move, so they are formed from the epiblast at the second week. Okay. So at week 2 of development. So these primordial germ cells are formed from the epiblast and they move to the yolk sac at week 2 of development. And then at week 4, the primordial germ cells, those are PGCs, migrate. So they start migrate from the yolk sac. So from the yolk sac to the developing gonads. To the developing gonads. Okay. To the developing gonads. To the developing gonads. We said gonads are simply sex organs. All right. So that's at week 4. And they arrive at the end of week 5. So now what you need to know is that as they migrate in week 4 to the developing gonads, they undergo various mitotic divisions where they mature and they increase in number. And they will reach these gonads at week 5. So this process takes place both in males and in females. But in females, okay, so in females at 3 months, so at 3 months of development, the primordial germ cells will differentiate into cells, specific cells called Ugonia. Okay, Ugonia in the ovary. The Ugonia. Now, these Ugonia will now undergo mitotic divisions and they will give rise, or they will differentiate into cells that are called primary oocytes. Let's look at it. Let me give you a table here. Okay, so the Ugonia, will undergo mitosis. All right, let me just change the color here. So the Ugonia will undergo mitosis. These Ugonia are diploid cells, meaning that they contain 46 chromosomes or 23 pairs of chromosomes. So the Ugonia will undergo mitosis and they will differentiate into primary oocytes. These primary oocytes are diploid as well. Okay. So these primary oocytes will now enter meiosis 1. So they will enter meiosis 1. So these will enter meiosis 1. Okay. So now the primary oocytes will be arrested. So the primary oocytes won't finish meiosis 1. So meiosis 1 is arrested at prophase 1. Now remember that prophase has got 5 stages. If you haven't watched our video on meiosis, you can find that description, that link in our description and in our comment section. Go and watch that video on meiosis 1. So prophase 1 has got 5 stages. Now the stage where prophase 1 is arrested is called the D protein stage. So the D protein stage. Okay, the D protein stage. So meiosis 1 is arrested at prophase 1 at the D protein stage of prophase 1. So when the baby is born with primary oocytes that are arrested at prophase 1. All right. Now, this meiosis 1 will resume. So meiosis 1 resumes. So it resumes and completes just before ovulation. Completes just before ovulation. Just before ovulation at puberty. So when meiosis 1 completes just before ovulation, it will give rise to a polar body. So this polar body is a non-functional cell. So to give rise to a polar body, and it will give rise to a functional cell here that is called a secondary oocyte. So secondary oocyte. This secondary oocyte and the polar body are going to enter meiosis 2. Okay. So even this polar body will enter meiosis 2. Like that. So they will enter meiosis 2. Let me just change. So this will enter meiosis 2. Now, when it enters, the secondary oocyte enters meiosis 2, it will be arrested at metaphase 2. Okay. So meiosis 2 is arrested at metaphase 2 until the secondary oocyte, until the sperm penetrates the oocyte. So when the sperm penetrates the oocyte, it will activate the secondary oocyte and meiosis 2 is going to complete, and you're going to have a mature oocyte that is produced. So what is produced after the secondary meiosis, after meiosis 2, is a mature oocyte. This mature oocyte is what you call the ova, which is the mature female egg. The other thing that is produced from a secondary oocyte after meiosis 2 here is a polar body. Remember, this polar body also enters meiosis 2 and it produces 2 polar bodies. So that is how oogenesis takes place in the females. So know its step and know where it is arrested. It is very, very important. Okay, so that was oogenesis. Let us look at spermatogenesis. So spermatogenesis. So spermatogenesis, this is the process. So this is the process by which male sex cells, so male sex cells, which are known as spermatozoa, are produced in the testes. So the testes are the male sex organs, specifically in the seminiferous tubules. So specifically in the seminiferous tubules. Like that. Okay. So spermatogenesis starts at puberty. So spermatogenesis starts at puberty. So those primordial germ cells that migrate to the testes they're inactive until the boy reaches puberty, which is around 14 to 15, around 12 to 14 years, somewhere there. All right. So what happens is that the primordial germ cells differentiate into cells that are called spermatogonia. So the primordial germ cells differentiate into spermatogonia. Okay, spermatogonia. Now this spermatogonia is in two types. Okay, so two types of spermatogonia. Spermatogonia. There is type A. So number one is spermatogonia A. Spermatogonia type A. When spermatogonia type A is produced, it indicates, so this indicates the start of spermatogenesis. Spermatogenesis. And then the other type of spermatogonia is called type B spermatogonia. So the second one is spermatogonia B. So this spermatogonia B is the one that will produce primary spermatocytes. So let's look at how it happens. All right. So spermatogonia type B. Okay, spermatogonia is going to undergo mitosis. So let me use a different color here. So it will undergo mitosis. When it undergoes mitosis, it is going to produce primary spermatocytes. So it will produce primary spermatocytes. These primary spermatocytes are going to undergo meiosis 1. So these will undergo meiosis 1. So meiosis 1. And then they will produce two secondary spermatocytes. So these ones here. So these are secondary spermatocytes. Spermatocytes. So what we shouldn't forget is that this spermatogonia was a diploid. Primary spermatocytes are diploid, but when they undergo meiosis 1, they become haploid. Okay, so each of these two secondary spermatocytes is going to enter meiosis 2. So this will enter meiosis 2 and produce two cells. This will also enter meiosis 2. So this will enter meiosis 2. When they enter meiosis 2, they are going to produce, each of them is going to produce two cells. The two cells that are produced here are what we call spermatids. So spermatids are immature sperms. So spermatids. These are immature sperms. These spermatids will undergo a process of maturation and specialization. This process here is what we call spermogenesis. So spermogenesis is just the formation of mature sperms. Spermogenesis. And through spermogenesis, mature sperms are produced from spermatids. So now we're going to have mature sperms that have got a head and a tail. Head and a tail. So that is how spermatogenesis happens in males. So now you need to know the structure of sperms, and you also need to know how spermatogenesis happens in the seminiferous tubules. So let me show you a picture of how spermatogenesis happens in the seminiferous tubules. Okay, so the spermatozoa that are produced, these are spermatozoa that are produced are haploid in number, just like the ova that was produced is haploid in number. So this is also haploid. It means it only has 23 chromosomes that are produced. Okay, so now let me show you how this spermatogenesis looks like in the seminiferous tubules. So this is how it looks like in the seminiferous tubules. Let me just try to enlarge this. Okay, so these are the seminiferous tubules. Okay, So this is a seminiferous tubule. This is how it looks like. Okay, so this is Spermatogonia, as you can see. Let me just change the color there so that it differs. Okay, so this here is the Spermatogonia. Spermatogonia. So the Spermatogonia. The Spermatogonia will now differentiate into the primary oocytes here. The primary oocytes would differentiate into secondary oocytes. So secondary spermatocytes rather. Secondary spermatocyte. Then this secondary spermatocyte would differentiate into spermatids. The spermatids will now differentiate into spermatozoon, which are the sperms. So this is the seminiferous tubules, and you have to know this picture because it usually comes. Okay, so Spermatogonia are differentiating until they become spermatozoon, sperm. This is a Sertoli cell. The Sertoli cell is a supporting cell. So supporting cell. It supports and it also provides nutrition to the developing spermatozoon. It also creates what we call the blood-testis barrier. Now, the blood-testis barrier protects the sperm from the white blood cells in the, so protects the sperms from the immune system, the white blood cells in the blood, the immune system. Because the immune system, if they enter the seminiferous tubules, they might attack the developing sperms. Because the developing sperms are just produced at puberty. They were not there at birth, so they are not recognized by the immune system. So they have to be protected from the blood. And the cells that create that protection, that barrier, are the Sertoli cells. Other cells that you have to know in the male reproductive system are the Leydig cells. Okay, so the Leydig cells produce testosterone by the influence of follicle-stimulating hormone. So this is how spermatogenesis happens in males. And that is how oogenesis happened, as earlier explained, in the females. Alright, I hope you gained some value in this video. You can register for lessons in our academy at +2 60975497790. So this was a demonstration video for our academy. There are videos on all the courses in anatomy, in embryology, in histology, and in gross anatomy. Register and you have access to all of them. All right, I'll see you in the next video.